So thank you very much all for attending, both physically and virtually. And I'd like to start out by having you imagine what you think of when you hear the word dog. What is a dog? Just take a minute. So for some of you, this may be a dog at home, maybe a pet waiting for you there right now. Or for those of you who are at home, maybe it's a dog by your side, maybe it's a working dog, maybe it's the dog that's photobombing me right now behind me here. But in all those cases, all of those dogs have something in common. All of those dogs are under the direct control of humans. They all are fed by us, usually with some sort of specially formulated food prepared for dogs. They are provided with shelter, water, medical care, and we're even controlling their reproductive behavior. While this is most of the dogs that most of us have experience with, this is actually not most of the dogs in the world. So how do we figure out how many dogs there are in the world? It's actually kind of a tricky thing to do, but we can estimate. And one way we can estimate is by looking at the ratio of dogs to people. So it's been estimated that there's about 1 dog for every 10 people. And if we assume there's about 7 billion people on the planet, that would mean that there's about 700 million dogs. Now, this is a really conservative estimate for a couple of reasons. One is that actually that number of humans has grown rapidly, and now we're at more like 7.125 billion people, but also because that ratio between dogs and people varies depending where you are in the world. So 1 dog for 10 people is actually pretty conservative. There's areas where there's 1 dog for every 5 people. So we can estimate another way. There are actually countries that have gone out and counted how many dogs there are in that particular country, and we can extrapolate that number to the rest of the world by using land mass. And when we do that, we get more like 1 billion dogs on the planet, as Jeremy mentioned. So how many of those dogs are under our control? Well, again, we don't know exactly, but we can estimate. And one way we can do that is by looking at the major pet-owning countries in the world. We all tend to calculate, make estimates of how many pets we have in each of these countries. And so these countries include Canada. The United States kind of disappeared up there, but it's in that sort of white box. Japan, all the countries in Europe, Australia, and New Zealand. And we add all of those pet dogs together, we get 17% of those 1 billion dogs, or 24% of our 700 million dogs. And that means that there's upwards of 83% of dogs in this world that are not under our control. They are free-living animals. So what does that mean? These animals are scavenging for their food from our waste and refuse. These animals are finding their own water, their own shelter. They don't have any particular medical care unless some organization goes out and vaccinates them. And they have complete control over their reproduction. Now, when you look at this dog, you may feel poorly, right? You look at him, oh, the poor guy, he's out there. It's probably, you assume that this dog was a pet, and some irresponsible owner took him out of that home environment that he was adapted to, that he was doing great in. He had all the food and water he needed and medical care. And for some reason or another, the person who owned him said, well, I'm just going to throw him out into the garbage dump and let him fend for himself. And he's not going to do so well there, and he's probably going to starve, right? We assume this animal's going to do very poorly. This is not where he's adapted to. And the science has backed this up. So we found that if you look at these free-living dogs, and when they do reproduce, we find that the pup mortality rate is much higher in these animals than it is in their wild relatives, other wild members of their genus, Canis. And we also see that their behavior, their reproductive behavior, is very different from wild members of the genus. They've lost a lot of the parental care that other members of their genus have. And we assume that this is because of either artificial selection, so in our striving to make them do certain jobs, to breed them into certain breeds, we lost some of that parental care, or possibly due to a lack of selection altogether. So these animals were originally living in our homes. That means that if they lost a little parental care here and there, we'd pick it up, right? Oh, you're not taking care of your puppy so well. Well, I'll feed it. I'll make sure it's okay. I'll give it what it needs. And so those young would then live and reproduce and pass on that lack of parental care. There's no selective pressure, right? And that's been kind of the assumption all along. But what I'd like to do today is give you an alternative hypothesis. I would like to suggest that difference in parental care is not degenerate. It's not something that they lost because of us. It's something they gained as an adaptation to survive in this very environment. And it's still controversial, I know, but that's what we're going to talk about. All right, so I'm going to push it even further and say, when you look at this dog has evolved to survive in this environment, and you shouldn't feel sorry for it. It's grew up in this environment. It's going to have puppies in this environment. They're going to grow up and have puppies in this environment. This is its natural habitat, and you should feel very much the same as you would if you saw any other animal in its natural habitat. All right, so to do this, I'm going to talk to you about a number of behaviors, all reproductive. So I'm going to review seasonality, age of first reproduction, pair bonding, and parental care. And I'm going to compare dogs to those wild members of the genus Canis, which will be represented by Canis simensis, also known as the Ethiopian wolf, Canis auris, also known as the golden jackal, Canis adustus, the side-striped jackal, Canis mesomelis, the black-backed jackal, Canis latrans, the coyote, Canis dingo, the dingo, these are getting easier, and Canis lupus, the wolf. So let's start out with seasonality. So seasonality refers to the tendency for animals to mate and consequently birth their offspring at particular times during the year. And this is adaptive because it allows them to have their offspring on the ground during food blooms. Lots of food is available. So where I come from in the northeastern United States, food blooms happen in early spring, as they do many places. And so a lot of animals are mating during the wintertime so that they can gestate and have their offspring on the ground when a lot of food is available. This means that it's more likely they'll get enough food, grow quickly, and be prepared for the tough winter months when there's definitely not enough food for everybody. And so what we see in the wild genus Canis is that all of those members that I mentioned are in fact seasonal. And it tends to be a fairly discrete time period during which they mate and have their pups. And so if we look at a single population over a year, everybody in that population has their pups on the ground within 1 week to 3 weeks of each other. So this is a small window. This isn't like 6 months or something. It's small. And it's not just that they tend to breed during those times. You know, they're just like, oh, I think I'll breed right now. It's actually a biological change. So if we look at the females of these species, they're all going through physical changes that make it impossible for them to reproduce at any other time in the year. And this doesn't sound too surprising to us, right? We're used to that happening, and humans go through biological changes that allow them to reproduce or not. But in all the males that have been studied in these species, so every species we've actually been able to get a hold of and look at, the males also go through a biological change that only allows them to reproduce during this one particular time. So this is at the level of physiology. Now, how about dogs? Dogs are not seasonal. And to illustrate that, I'd like to point out some data. These two graphs both have the same axes. So on the horizontal axis, the x-axis, we have day, one representing January 1st, right, and then going on from there. And on the vertical axis, or the y-axis, we have day length. So if you look at those curved lines, that's just showing you how long the day is. And if you're paying attention, you'll notice they're in opposite directions on the top graph, which is our dog, and the bottom graph, which is our wolf. And that's because the dogs are from Australia, and the wolves are from the United States. So they're in opposite directions. But what's really important on this graph is the little X's on that line. And those represent matings. And so in the wolves, you can see that all those matings are clumped together in the wintertime. And in the dogs, they're spread throughout the year. No seasonality. And this seems like maybe a really bad idea. At first blush, it seems like it could be degenerate, right? This is happening because we have them in our homes and it's snuggly and warm in our homes. And so if they birth a pup in February, it's fine because we have central heating. It'll be okay, right? And we'll provide them with food. It doesn't matter that there's nothing to eat out there. But we actually see a lack of seasonality in some other animals as well. And where we see it is near the equator, in the tropics, because there isn't a big change in seasonal pulses. There tends to be about the same amount of food available throughout the year. We no longer have a predictive change over the year. And so it doesn't matter when you have your offspring because there's always going to be enough food. We don't have to worry about that nasty winter weather approaching because it's going to be all right. It's going to be all right the whole time. And I'm suggesting that that's what's happening in the garbage dump as well. Not sure if you believe me. There we go. So since we started to be able to put food in containers, to store food, we've started to have a more steady availability of food. And when we have a steady availability of food, we have a steady output of garbage and refuse. So in the garbage dump, there is no longer a reliance on change in sun availability or water availability. It's all about how much garbage we produce, and we're really good at producing garbage. And so it's there all year long. Now, I'm not saying it's constant. There are times when maybe there's a big disease goes through and there's less people around, or there's an unexpected flood or something like that, which would change availability, but it's no longer determined by the season. It's no longer this predictive pulse. So you don't need to get your pups out on May 1st. You could do it anytime, and it's just as likely that this would be a good time of year to have your pups on the ground. Not only does it not matter that you don't have them at a particular time of year, but actually spreading out when pups are born could be a good thing. Because when you have all of your pups born at the exact same time, everybody's competing for that food pulse, right? There's still a limited amount of food available, even though there's more food. And so all the moms and dads are out there trying to get as much food as they can for their babies, and some of them aren't going to make it. But if you spread all the pups out over the year, then you decrease that competition between the pups. So if you don't need seasonality, it's probably a good idea to get rid of it. All right, so our next topic is age of reproduction. Now, age of reproduction actually turns out to just be a byproduct of how big you are. So in order to reproduce, you need to reach adult size. That's how you can reproduce, right? You have to be the shape of an adult to be able to reproduce. And so what we see in the wild canis is that the smaller you are, the earlier you reproduce, and the bigger you are, the later you reproduce. So here's some of the smaller members of our wild species. On the left, we have our coyote, in case you didn't recognize him over there. And they're on the small end. They're 9 to 18 kilograms for our people who don't work in kilograms. Multiply by 2, it's pretty close, all right? That gets you pounds. So 9 to 18 kilograms, they tend to reproduce at either 1 or 2 years. Now, why the range? Well, if it's your first year and you have a good year, then you got lots of food, and that's an excellent spring, then you can make weight really quickly. But if it's a crummy year, then you might not make 9 to 18 kilograms in that first year. So you have to wait till the next year to put on that extra weight and reach your adult size. And there's a little added catch here. It's not a full year. Remember, they're seasonal. So from the time you're born to the time you could possibly have that first biological change and be reproductive, you really have 10 months. And if you aren't big enough at 10 months, you gotta wait till the next year comes around, all right? Our side-striped jackals are small. They're only 7 to 10 kilograms. They make it in the first year, no problem. Our golden jackals are also 7 to 14 kilograms, and they're, again, 1 to 2 years, much like our coyotes. If we bump up a size, we see that we're getting a little later reproduction. So our Ethiopian wolf doesn't reproduce until 2 years. Our dingoes tend to reproduce at 2 or 3 years. They actually have been seen to reproduce at 1 year, but it has to be a really flush year. And then our black-backed jackals, again, at 2 years. And these guys are all a little bit bigger than our last crowd of canids. And then our biggest guys are our gray wolves. And they're around 22 to 50 kilograms, and they don't reproduce till their second or third year. Actually, there's been evidence of some gray wolves not reproducing until their fourth or fifth year. That's getting towards like the average age that they survive. So it can really get pushed out pretty far if you get a really crummy life span and you hit some really bad years there. Again, if they're in captivity and they have all the food they could possibly eat, we've seen these guys reproducing in their first year. But even with that, sometimes they don't make it. All right, so how about our dogs? Our dogs reproduce in their first year, and they're around 13 kilograms. And some of you are going, what? Dogs are around 13 kilograms? They're around 30 pounds, around 26 to 30 pounds? But they're the most varied animal in the world, right? We have our Chihuahuas. They're 7.4 pounds or 1 pound or whatever, right? And we've got our Great Danes, and they're huge. And how can you say that dogs are 30 pounds? Well, I'm talking about these 83% of dogs in the world, these free-living dogs. And if we look at all the dogs that are free-living in the world, they all tend to be the same size and shape. They can vary in coat color, but they tend to all be around 30 pounds, around 15 kilograms. And if it's really hot, they get a little smaller. And if it's really cold, they get a little bigger, which is clinal variation. We tend to see this in any naturally occurring species. So this alone, the fact that they're all the same size and shape, is already pointing out maybe some natural selection is happening here. This is a good size and shape to be in this environment. And it's small, so they can reproduce in their first year. And not only can they reproduce in their first year, but they can have a full 12 months to do it, right? They don't have that cutoff at 10 months. They could reproduce at 11 months, 12 months, 8 months, doesn't matter, whenever they're ready. Okay. Next, we have pair bonding. And pair bonding isn't really a discrete category. We lump it together. But it really compromises several behaviors. The first being cooperative territorial defense. So this is something a mated pair is doing together. And they have some sort of territory, and they're defending it together. They're also defending each other. They're guarding their mates. So males will chase off other males, and females will chase off other females. And finally, they're caring for their young together. So this pair bonding behavior is attached with something called mating strategies. And so there's a variety of mating strategies. I'm not going to go through all of them. I'm just going to talk about the two pertinent ones. One is monogamy, which should sound probably pretty familiar to you. Monogamy is when we have exclusive mates, right? We have one female and one male. They only mate with each other. And this can be just for one season, though. I mean, we tend to think of, humans, and we think it should be a lifetime. But sometimes it's just for a mating season. Sometimes it is over the whole lifetime. And the swan, which we use as kind of a symbol of monogamy, right? It shows up on wedding cakes and on Valentine's Day cards and everything like that. They're monogamous. But there's actually two kinds of monogamy. There's true monogamy, which is what I've just described, where they are exclusive to each other. And then there's the more common social monogamy, where what's really happening is it all looks great up front, right? Everybody's pair bonded, they're taking care of their kids together, it's really nice. But what they're doing is they're sneaking off and mating with their neighbors when nobody's looking. And this actually turns out to be what most monogamous species are doing. So we thought all these songbirds were monogamous and it was so beautiful, and then we realized they were all mating with their neighbors when nobody was looking. So that's called social monogamy and tends to be much more common. But even more common than social monogamy is polygamy. And that's what our mallards in the background do. So males mate with multiple females, females mate with multiple males. We have no pair bonding, it's a free-for-all. The females do tend to be pretty picky though, because at this point the only thing that the dad is donating is his genes, and so she wants to get good genes. And she has her choice, right? The males are just trying to reproduce as much as possible, and the females are picking out who they would like to reproduce with. So females tend to be choosy. Sometimes you see a little choosiness in males. All right, so how about our canis? Well, our canis, all of our wild canis are monogamous. But are they truly monogamous or socially monogamous? Well, we actually haven't done studies on all of them, but we do have some research on two species. One is our Ethiopian wolf, a very endangered species. And they looked at the genetics. Basically, they have to go and get samples of genes from all the fathers and all the pups and see if all the pups in the litter match with the father who's taking care of them. Right? They can also match the pups to each other if they don't have the father's DNA and see how closely they're related. And so in Ethiopian wolves, it turns out that, as we might suspect, they're only socially monogamous. But it might be because they're in a really disturbed habitat. These animals, they have very little habitat left, and we find that when a pup when they grow up, they need a new territory to actually have their own puppies. It's not just being able to biologically reproduce, but they have to go out and find a territory of their own and a mate of their own to start everything over. But in Ethiopian wolves, there isn't enough land to do that. There's not enough habitat, good habitat. You go out, there's nothing there. And so what tends to happen is that when a parent dies, an older pup takes its place. And so you have daughters mating with their fathers and a lot of inbreeding, which in animals is also not a good thing. We tend to have sort of a taboo against it, but there's a biological reason for that. Inbreeding tends to lead to issues, as we all know with our purebred dogs. If you inbreed too much, you start to get some deleterious effects. And so what we find with the Ethiopian wolves is if you had a female who's mated with her father, what she does is she leaves her family group. So she doesn't mate with her brothers. She leaves her family group and goes next door and mates with an unrelated wolf. And so that might just be a byproduct of the really crummy habitat they have. We don't know. The other species we've looked at is coyotes, who I hear is the local hockey team as well, so you should be happy. So coyotes, there was a great study done in 2012 by Hennessy et al. And what she did was she looked at 236 coyotes in the Chicago area. So this was a nice big sample size. And she had 18 litters comprising 96 puppies, okay? So she was out there a long time. This is not a quick study. And she got all this genetic material, compared them to each other and their fathers, and she found zero evidence of cheating. They are truly monogamous, which is, a scientist is blown away by this because this is such a rare thing to have true monogamy. And the main reason is because it's usually not beneficial to the male to be monogamous in the first place. For them, the best thing is to spread their genes around. The only time we get monogamy is when a female can't raise her litter by herself. So if you spread all your genes around and all your offspring die, that's not adaptive for the males, right? If the female cannot support all her offspring on her own, that is not adaptive for the males to run around and reproduce a lot. He has to stay home and take care of those puppies as well. And so that's when we see monogamy. But even when we have that, sometimes it's good not to put all your eggs in one basket. And so that's why we see that sort of sneaking around. Maybe the female ended up with not the best male in the area, and her neighbor's really a lot better genes, and so she sneaks over there. Maybe the male is like, yeah, I'll take care of these puppies, but I wouldn't mind having a few over there just to spread things out a little bit and make sure my genes do get passed on in case something horrible happens over here. So true monogamy is really unusual, and we see it in the coyotes. So just as a little side note, I would suggest that next time you have to send a Valentine's Day card or maybe set up a wedding, instead of putting a swan on it, you might want to put a coyote on your wedding cake. All right, so how about our dogs? Well, our dogs are completely promiscuous, as you might imagine. Males mate with multiple females. Females mate with multiple males. We see no territory guarding, we see no mate guarding, we see no, as we'll talk a little bit more in a minute, we see no paternal care. That black dog there in the middle, that's a female. Those are males all hanging around. She's in heat. They're just going to wait their turn. We actually see them like line up behind each other. We do see a little pickiness. Females can be picky, and males, they prefer 2-year-olds to 1-year-olds. And it may actually have a biological reason why they prefer older women, so to speak. It might be because the 1-year-olds tend to lose more pups. They just tend not to do as well. It's their first litter. All right, so completely promiscuous. This ties very closely in with parental behavior, of course, because with the pair bonding, we get more complex parental behavior. Now, Canis, all members of the genus Canis are mammals, and so we know they nurse their pups at least. Parental behavior in the animal world is actually kind of a rare thing. We don't have a lot of parental behavior in the larger picture, but in mammals we have to have it because we have that milk, right? So automatically, default, we've got some parental behavior. But in the genus Canis, we actually have really complex parental behavior. It's actually unusual in the animal kingdom. So not only do the mothers nurse, but we have this paternal care. And so the paternal care comes in a number of levels. While mom is nursing, she's not great at running around and hunting. She's stuck with these puppies. And having raised wolf puppies, I can tell you it is a 24/7 job. They are drinking every 4 hours, around the clock, and she's got a bunch of them, right? So she's got, 4 or 5, or maybe 6 is high, but she could. So she's busy, she's full with milk, she's not a great hunter at this time of her life, and so dad goes out and gets some food and brings it back to her. And often he'll regurgitate, so he'll eat the whole thing and regurgitate it. And this isn't just in wolves, this is in all of these members of the wild genus Canis. Then, when the pups are a little bit older and they start to be able to chew, both mom and dad start bringing home regurgitant for their pups. So what they do is they go out, they get a kill, they eat some of it, and they come back, and the pups will solicit. They'll beg, just like this. They lick the face of the adults, and reflexively, the adults regurgitate. And the pups eat it. Now, this is really often during the day. It's been calculated in black-backed jackals that this occurs 7 times a day. And in the side-striped jackals, they found it happening every 2 hours. So they're really surviving off this food. It's not just like, oh, you have a little extra, here you go. They are really, this and the milk they're surviving off of. They get weaned around 10 weeks, regurgitation continues. Sometimes around 14 weeks, but if they don't have pups the next year, it's been seen that some adults will continue regurgitating even at a year old, right? So if they have no new puppies, they'll keep regurgitating to their older puppies for even longer. Then, once the pups can move around a little bit better, they'll bring and chew a little bit better. They'll sometimes bring back chunks of meat, so they'll provision with like a leg of something, or in the dingoes, they'll bring back a leg of a kangaroo, or if you're, an Ethiopian wolf, maybe you bring back some sort of African ungulate. The problem with provisioning as opposed to regurgitating, especially in some place like Africa, where there's a lot of other predators, is they can be stolen. So you bring back a nice chunky leg and a hyena grabs it from you, and that's not so helpful. So regurgitation often continues through this time as well, especially in our African members of our Canis, because you can hide the food there really well. And then, along with the parents, because it's so tricky to go out and find your own habitat when you grow up as a Canis, oftentimes they'll stick around. And that's how we get these packs, right? We have mom, we have dad, we have older siblings, and then we have new siblings. And so the older siblings hang around, and they too regurgitate to the pups. So the pups will beg to them, and they'll also provide regurgitant. Now, this is a little sneaky, because we used to think, we thought this was very altruistic, right? Oh, they're sticking around, and they're taking care of their brothers and sisters, and that's fantastic. And we thought it was something called indirect fitness. And so what happens normally, when you have direct fitness, you have 2 parents, they have offspring, and they each donate half the genes to the offspring, right? So this new baby has 50% of its mother's genes and 50% of its father's genes. And so evolutionarily speaking, it's beneficial for the parents to keep pushing those genes onward, and so they take care of that pup, it survives and reproduces and passes its genes on, okay? So that's just direct fitness. Same thing when they have pups the next year. But it's not just the parents who are related to each other. The siblings are also related to each other. Let me get this guy out. So the siblings don't share as many genes. They only share about 1/4 on average of their genes. But if you're an older sibling and you take care of 2 younger siblings, it's like taking care of your own baby, right? That's great. So you get 2 more babies out, and they might not be yours, but they're really closely related, so they're still pushing your genes forward, and it's still evolutionarily beneficial to you. And so that's what we thought was happening. And then we looked a little closer, and we found out that when it's a really good year, the story I just told you is exactly what's happening. But when there's not enough food, the older pups are actually stealing from their younger siblings. So they'll regurgitate, but then they'll eat it right back up, or they'll eat other regurgitant from the parents. And so they're not such great altruistic animals when it's not going so well. So in a good year, they're either not affecting their siblings or they're helping their siblings. They're actually improving the survivorship of their siblings. In a bad year, they're actually reducing the survivorship of their siblings. And this might seem evolutionarily bad, but it turns out, and I'm gonna ruin all your days if you have siblings, especially if you're a younger sibling, but what it turns out is that if you've put a lot of energy into an offspring, and they're close to reproductive age, you want to keep putting more energy into that offspring because it's more likely that they'll reproduce. And the younger offspring may not make it the next year, right? They may never reproduce. We don't know. It's a long way till they get to reproductive age. So we often see parents putting more energy into older siblings. Sorry. If you are younger, I'm a younger sibling, so tough luck for me. All right, so we do have this sibling care, though, and so it looks like it's a byproduct. We have this really important regurgitation behavior. It's super important to be able to regurgitate to your pups. It's really reflexive. I've seen wolves put in with completely unrelated pups, filled up with a nice steak dinner because we wanted the pups to get to know older wolves that they're going to live with, right? So the older wolf goes in, nice big belly of steak dinner, and there come the puppies, and the older wolf will keep his head up in the air and try to do everything in the world not to get licked in the face, right? Hop up on things, run. Eventually the pups get to him, they lick his face, and there goes the regurgitant, and that's the end of it, and they let them have it. And so it's very reflexive. So probably what's happening is that it's just a byproduct of having to stick around with your parents. So you're there, you're with your parents, and there's puppies, and they're begging, and you regurgitate. And sometimes it's good. All right, how about our dogs? Dogs are mammals. We all hopefully know this. So they have to nurse, right? So we have some parental care in that way. We no longer have this pair bonding, so we no longer have paternal care, and we really don't see regurgitation. Now, it happens sometimes. It's all but disappeared. So there's actually some studies done in India by Pal, where he watched these guys really closely to see what the mothers were doing with their pups. And he did see some regurgitation. Didn't tend to be preceded by begging, and the frequency was really, really low. So instead of 7 times a day or every 2 hours, they did it 5 times a week. And it stopped with weaning. Once the pups were weaned at 10 weeks, no more regurgitation. That was it. Once you're weaned, you're out of here. I'm done with you, right? I don't need to deal with you anymore. So we've really lost a lot of no sibling care, no paternal care. It's all gone. Just nursing and a little regurgitation before you're weaned. Not enough to really survive off of. So this is one of the main reasons that previous scientists have said this is degenerate. This is a bad deal. They've lost some really important behaviors here to keep puppies alive and going, right? And we see a lot of these juvenile pups after weaning that look really crummy. They don't look so good. It's not going so well for them. And so this is one of the main reasons that we thought, well, you have to have more pets coming in. You can't survive on their own. So what's happening here? How can we possibly make this a good thing? How is this adaptive? Well, let's go back to our wild canis for a second. In the wild canis, you have to be adult-sized before you can forage for yourself. You're going out and you're hunting. Hunting is actually kind of a tricky thing. The bigger you are, the harder it is, actually. So the smaller animals, they have to hunt rabbits and mice and smaller things. But our bigger animals, like our wolves, are actually having to do cooperative hunting, which is even harder. And we actually see that they aren't even very good at it until they're 3 years old. They can do it, but they're not pros until they're around 3 years old. So, and they can't do anything at one. They can't catch big things. They can catch mice and grasshoppers and stuff like that, but not anything sizable or significant. So it takes a while to get your offspring from weaning to surviving on their own. It takes quite a while. And so you have to have that parental care. Not only does it take them a while to get to hunting, but they also have to go find this territory. They have to do all sorts of stuff to be successful on their own. And so oftentimes, we'll see a young offspring, a year or two old, he's starting to be able to reproduce, goes out into the world to find its own territory, and there's nothing there, so he comes back home. It's kind of like us, right? Go to college, it was great, there's no jobs, go back home, right? Very similar. So it takes a long time to raise these animals. They're very complex adult lives. And so it takes a long time to get them so they're out the door and they're actually succeeding and not just going to die out there. That's not useful after you put all that energy in. But what about dogs? Dogs are living in this garbage dump niche. In this garbage dump niche, you don't have to find your food. You sit there and it comes to you. You don't have to chase your food. It's a rotten melon. It falls on the ground and you chew it up, right? Not a lot of processing involved here. Not a lot of cognitive skills involved in eating a rotten melon. So you just hang around, food shows up, and you eat it. So they can do this once they're weaned. In fact, we see them in these free-living populations. We see pups doing this before they're weaned. They'll walk over to the garbage dump, and they'll eat some food, and they'll suckle, and then they'll go to sleep. And then when mom goes away, they just go back out, and they eat the food, and they do what they were doing before, right? It's really not complex. So they don't really need all that parental care. And not only do they not need it, but it's actually beneficial to the dogs to skip it altogether. As I mentioned, it's a rare thing to have this much parental care. And what's happening with our wild animals is all that energy they're putting into their offspring is taking away from them. And that whole idea of needing to reach a certain body size to reproduce, that holds your whole life. So you're losing a bunch of body weight, putting it, nursing takes a ton of body weight, right? So it's taking all that conditioning, taking all that food you could be eating for yourself, and you're giving it to your puppies. You're providing your puppies with all of that stuff. And so by doing that, you're making it less likely that you'll be able to recycle and reproduce the following year, right? The more energy I put into last year's litter, the less energy I have for next year's litter. So there's a big trade-off there. If I don't have to care for the puppies after 10 weeks, I can recycle right away, right? I start eating food, it's great. I'm fat and happy and I can have another litter. Not only that, but with the wild Canis, they have to recycle by that distinct date, right? They have a timer. If you are not ready at this date, too bad, you have to wait till the next year. The dogs, I get rid of this litter. As soon as I'm ready to reproduce again, I can have another litter. So on average, dogs can reproduce every 7 months in these free-living populations. You often hear dogs can reproduce twice a year. It's not quite true because it's possible they could reproduce every 6 months, but that's really pushing it. If you see dogs who reproduce every 6 months, they look pretty bad condition, even if they're being cared for by humans. So on average, it's every 7 months. Sometimes, there'll be a dog every 12 months. There's a dog that's every 6 months. But on average, it's every 7 months. And if we consider that the average free-living dog lives for 4 years, in a free-living dog population, only 5 to 8% of the puppies need to survive to maintain the population level. 5 to 8%, that's barely anything. So they can switch their game from one of quality, like our wild Canis, who are putting a lot of effort into making these really complex beings, right, that can hunt and do all this really complex stuff, to one of quantity. You just pump a lot out there, and some of them make it. Not a lot of them have to, and that'll keep things going. So they've changed this strategy. And they've changed this strategy according to this niche, this new environment that they live in. They no longer live in this environment where they have to go catch their food. They live in a garbage dump. So they've lost their seasonality, but they're in an environment that is no longer seasonal. They've lost their parental behavior, but they're in an environment that no longer requires that. And in fact, it's adaptive not to have it. All right, so just one more side note here. There's another thing that probably led us to think that pet recruitment was necessary for these animals to continue surviving, and that is the idea of the niche. So this little blue circle is our niche. We're going to call this the garbage dump, and this is the environment that these animals are adapted to. So outside of that environment, they do poorly. Inside of that environment, they do well. They have all the garbage. They can sit there. It's not seasonal. All this stuff they've adapted to. But it's discrete. It can only take so many animals, right? You can fill it up. And once you have enough animals in it, if you put another one in, it won't do well. There's not enough food for it, okay? So if it's in that environment, there's not enough food for it, it will die. So imagine you have a garbage dump, and it's full up with our free-living dogs. And somebody is irresponsible and lets their pet dog out and says, there's a lot of dogs here. You'll be fine. Go survive on your own. Well, they're coming into an environment that's already filled up. If they stay there, they're pet dogs. They are a different shape than these dogs that are living here. They are not well adapted to this environment, and they will be outcompeted. So the only hope they have is to leave that niche. If they can find another garbage dump that's not so full, they might do all right. But most likely, they'll just move out of it, and they'll be in a not such a good area, right? They'll be outside the garbage dump trying to survive, and that's not going to go well for them. They're going to die. All right? So those pet dogs coming into the garbage dump, a full garbage dump, they get pushed out. They're living on the fringes. They're not doing so well. The only way that population is going to continue is if we have more pet dogs entering, right? And that does exist. We have these little populations of stray dogs that have strayed from the pet population, that aren't doing well, and aren't going to reproduce well, and are just going to die out. But that is not most of our 83% of our dogs. Most of our 83% of our dogs are in that circle, doing just peachy. However, this does have other implications on those 83% of the world's dogs. So if you have a baby in one of those really full areas, right? You're full up. The only way it can survive is if somebody else dies, right? We're at capacity. There's no way that baby can live in that environment unless somebody else dies. Its other choice is to leave the environment and hope it finds another niche. All right, so we're not doing so well if the niche is full. And this is probably why in most of these garbage dumps we see really healthy adults and we see really healthy neonates. The guys who are still suckling on their moms, they're doing awesome. But as soon as they leave and they are weaned and they have to fend for themselves and compete with bigger dogs in an already full environment, they don't do so well, okay? If somebody else dies, they can take their place. If they find another garbage dump, they'll be okay. but in that environment, in that full environment, they're not going to do so well. But we'll keep the population steady, because as soon as somebody dies, there's somebody to take their place. However, if it's an empty niche, the Olympics came through and we culled them all. There was an outbreak of parvo. It's a new garbage dump. We moved in, and now we've got lots of new garbage. Then dogs are fantastic at filling that niche up, because their fecundity, their rate of reproduction is so high. They will reproduce as often as they possibly can and quickly fill this niche up. So, in conclusion, we have dogs who have lost their seasonality and lost their parental behavior, but they're doing so in a niche where this is adaptive because they no longer have seasonal pulses and they no longer have need for long-term parental care. Their foraging strategy has changed. And so I'd like you to think about how you can take this message further. If we think about dogs as an animal that's adapted to a natural niche, right? One we created, but it's out there. They're under the natural selection pressures. They're adapting to this. It's not us who's forcing them to do this. They're going through a natural evolutionary process. It wasn't until later that these animals came into our home and we bred them and did all sorts of things to them. So if we understand them at this level, it really helps us with not only managing these populations, but also thinking about how we interact with them once they come into our homes. And before I go to questions, I'd just like to mention that all of this is from a paper that I wrote. It's published in Behavioral Processes, and I wanted to mention my collaborators, Mark Feinstein, Bradley Smith, and Raymond Coppinger. And I'd also just like to thank all of the people here behind the scenes making us look good. There's a whole lot of them that especially the people on the live broadcast can't see, so thank you all as well. All right, thank you very much.